Hi everyone. Um, okay, let me mute myself. Cool. So welcome. Thank you for coming here. Can you hear me? Nice. Okay, great. So this is the first session of our course that's going to last for about 10 to 12 weeks. My name is Luca. I'm machine learning engineer and head of education at MatchBox. Um, I hope to help you all here learn about machine learning and uh, to potentially unlock some new opportunities for all of you that would like to go and embark on data science or machine learning journey. And we are going to really dig into practical stuff. So there will be some theory along the way, but mostly we are going to focus on practical stuff so you can apply in any job that you're doing. Are you a web3 developer or web developer or just any like a backend developer, for example? You'll be able to use the skills that we are going to cover in the course for your day job, or potentially find a way into data science jobs as well and fully work there. Before we start, I would like to hear more about you, where you're coming from, what's your background, do you know Python and stuff like that. So yeah, let's start with that. So while you type, I just like to say that this session is going to last maximum 3 hours. So we are going to focus on core materials to cover in 2 hours, since they are heavy materials that we are going to cover in upcoming weeks. And the last hour or so, we are going to speak about general stuff, um, either like prolong those 2 hours if we have something that really need to be covered that day. We are going to speak about projects for that week and stuff like that. So yeah, we are going to focus on 2 hours content and then 1 hour or so either to cover the content that we hadn't had chance to cover in those 2 hours, or move to more like logistical part like Q&A session, kind of an office hour and stuff like that. Okay. Uh, Nice to meet you, Daria. Amazing that you're coming from NYC, one of my favorite cities in the world. And great that you're brand new to Python. Great, nice. Okay, we have one economist. So great. Um, you have background in statistical analysis, amazing, and PhD, amazing. Cool. Um, so you will find this content that we are going to cover useful. All the things that can be done with statistical analysis can be extrapolated as well with machine learning, and we are going to talk about the difference in the next week. This week is mostly for you to get your hands dirty with Python. So we are going to speak about Python as a programming language. We are going to do some exercises together, and this session is mostly for everybody who would like to either refresh the Python knowledge or that never worked with Python and would like to um, just get a sense of what Python is and why we use the Python for data science and machine learning content. And the next week we are going to jump straight into machine learning and classification, what is machine learning and stuff like that, and do some starting projects with it. So yeah, just so you know, my live stream is 4 seconds behind. So when you write a message, there will be some delay until I answer. But yeah. Okay, cool. So we have okay. Um, oh, we have Luca from Kraljevo. I think we met already. Am I thinking about the Luca that we drank a coffee together some time ago? Nice. Welcome, man. Nice to have you here. Great. Yeah, so we have great people here, and if you're ready, we can. If you have any questions for before we start with like a more logistical part of the whole content, do you have any questions for me that I can answer straight away? Okay. Okay. While you type, um, VS Code is completely okay. So okay, one that's a great question. Let me immediately share with you the screen that we are going to work with today, so I can so you get a sense with. Okay, so the tool, or I would say the IDE that we are going to utilize throughout the course, is going to be Code Colab, Google Colab. You can use anything that you like you can use VS Code, you can use PyCharm or any editor that you feel comfortable with, but anything that you're going to use locally installed will require some setup. We're going to speak about Python setup and installation just in a moment, but that can cause some problems for like potentially some of you, because like I'm using, for example, on this computer that I'm streaming with, Windows, which is really simple to install stuff. But then when we go to areas such as Mac or Linux, that actually completely change the workflow or installation process of some tools. And for that reason, I opted to use this online editor, which is by Google, so called Google Colab. We are going to set up Google Colab right now. Just the idea is so we can only focus on the core content, and I will point you to some directions on installation if you like to have everything that we are doing locally. That's one reason. The other reason is later in the course we are going to work with a bit heavy workloads in a sense of crunching time and pre-processing and writing a neural network that needs to be trained. And if you have a simple laptop, well, then you're going to be screwed a bit. And because this is free, this is completely free, you can do everything from your browser, no question asked, and that's basically great benefit of the tool that we have in front of us. I hope I I clarified why we are using this tool, but thanks for the question. And hi, Ash. I'll call you Ash. I don't know. It's a bit longer name. Cool. Okay. Okay. Cool. Thank you. Thank you for clarifying. Yeah. So why Python? Well, Python is first of all a really high level language that you will see some of the comments that if you had previous experience in some any other basically programming language, Python is really close to English. And data scientists are using Python because we have so many libraries today that help us to solve really complex problem without actually thinking twice about the logical or thing that needs to be done in the backend. And that's reason why we're opting for Python and not R or some other language that is still supported for most of the tasks in data science. But actually Python is the really king of all programming languages for data science so far. So what is the structure of the whole course? Every week we are going to come in on this stream. We are going to go through a certain lesson. This week we are speaking about, if you scroll down here in this document, we are speaking about Python. So just introduction to Python. And you already have the worksheet that I'm going to use throughout the live stream right here in the Notion. The full code, as in like correct answers or answers that I'm going to populate throughout the session, you will have the code right here. And there will be like GitHub repository for projects and stuff like that. So every week we'll have a live stream that's going to be 2 to 3 hours long. Sometimes we'll have even more than 3 hours when we start speaking about more complicated topics. I'm sure that there will be a lot of questions that needs to be answered, either from practical side, like from my experience, or from your like justificational side, like, hey, I had a problem installing something or something like that. So this week we are here right now. The next week we'll have an office hour. We'll start with office hours. Those office hours are 45 minutes to 1 hour long every Wednesday. And I think it's at the same time, 5:30 CET. Those are optional. You don't have to come if you don't have any questions. So obviously, office hours I'm here for you to answer any questions. We are not going to cover any further. So if you miss an office hour, you're not missing a lot, except potential questions that you had, but your colleague had as well. And then we are going to have, again, another live stream of 2 to 3 hours and so on. Some weeks, starting from the week 3, we are going to have guest lectures. So guest lectures are going to be conducted by professionals from all over the world on different topics. And because I needed to organize them from like US to India, they are going to be a bit different starting points than our live streams and office hours. So you can find their starting times here, all converted in CET. So you can easily convert to your time if you're coming from a different time zone. So starting from the week 3, we are going to have a talk by Tobias. He's coming from Germany, has amazing startup, and he's right now consulting on business intelligence and wrote a book from O'Reilly on business intelligence. So if you never heard about business intelligence, or you just like would like to learn about it and broaden your knowledge into that area as well, that's amazing session for you. So you can ask any question to him. He'll be on Zoom with me, so I'll interview him. He will give a session. You will ask questions and stuff like that. So it's everything like for you to learn as much as possible. I see new people joined. Hello, everyone. Thank you for joining me here. So yeah. Then we are going to have Marko Velic. He's coming from Croatia, leading engineering for Photomath. So amazing organization. So I worked for that organization last year. They are basically creating an app that can scan any mathematical formula by taking a picture of it, like OCR. We're going to learn about OCR later in the course. And yeah, so basically all of that. And he's going to speak about how is actually ML driven organization different than traditional like organization, you know, from engineering standpoint. He worked at Facebook, now Meta. He was engineering manager, so he led crazy big team for ads at the Facebook, and you will be able to ask him everything about that. How is the Meta organization structured? Is it different from any organization that you work for? And what is basically the current organization in the company that he's leading? So he has 400 engineers under his name right now. Then we'll be joined later, like March 6th, by Sayak. So he's my good friend from Google Developer Experts. And he's now one of developer relations engineers at Hugging Face. If you never heard about Hugging Face, so don't worry. It's an amazing organization that will help all of us right here to make great products. And he will introduce us to Hugging Face, and we'll start after that session working with that product as well. So you will be able to ask him everything about that. Then we'll be joined by George from Greece. and he will talk about how to actually use deep learning on edge devices, like IoT devices, mobile phones, and stuff like that. So if you're interested on how to use like a neural network for detecting like spam on device like this, he will teach you. Then we are going to jump into something that is potentially relevant to all of us right here, and we are going to speak about large language models. So ChatGPT, GPT-3, GPT-4. What's GPT-4? Is it going to be really different from GPT-3? From technical side of things, we're going to understand that and at this session here. And last session is still in debate. I need to think to speak with David, but if he joins us, he will speak about flags or jacks. If he doesn't join us, or yeah, he has some things to do. He's moving to another country, so he's a bit all over the place right now. I will find some other guest speaker and inform you in a timely manner. But basically, yeah. So that's the guest lecture. So you will be covering all the areas of machine learning, most of the areas of machine learning, and those that are not covered by guest lectures, we're going to cover by materials for the course as well. Cool. Oh, hi, Bruce. Nice to have you here. Amazing that you joined us. Cool. So basically, that's the structure. Okay. So a bit more about the whole course and who is organizing that and what is the communication going to be like moving forward. So so far I contacted all of you by email, 3 emails that I sent you so far. I won't do it anymore. So I will not spam your inbox anymore. So every communication that's going to happen regarding the course is going to be organized through Discord. So you have this Discord URL here that you can use to join. So the Discord community is for all the developers connected to MatchBox. So some of them are for Web3, some of them are there for game design or in game development, and some of us are here for most technology right now for AI. So the communication is going to happen under machine learning course. So you will publish your material, stuff like that. You have study rooms to connect with other participants, to study with them if you need something like that, and stuff like that. Then basically each week, as I said, we'll have those things. And each week I will give you some quiz that will summarize the content that we did that week. Not this week. So this week, no quiz, no take-home exam. So you will be just here to learn Python and ask questions. The next week we'll start with quizzes and take-home exams. So it won't take a long time. So you will sit down, summarize the content that we learned, and write a simple program that solves, for example, predicting house prices in Boston. So that's basically it. Like nothing spectacular, but when we go through content, you will have more advanced topics such as object detection, creating a classifier that can be put on a phone and stuff like that. We'll talk about them in a bit. There will be the deadline for submitting all of those, but you don't have to comply. So hear me out. The only people who submit everything by time deadline that I set, and I will go through materials or submitted projects myself, so I will grade them. Basically will be qualified to join me and others from MatchBox as an advisory or machine learning engineer or data science on projects that we are currently looking forward to. So people from MatchBox are currently looking for some like companies and stuff like that that will like create some projects that we can solve. So we are currently looking for partners on that area. I can't promise anything as a deadline, so you will be reached out by me or somebody from the MatchBox in a timely manner. I'm not it's not 100%, but if you would like as an extra job, that's going to be for you. So it's an extra job. It's not full-time job, just to clarify that. Okay. And one interesting thing is if you go through calendar, somewhere in March or end of April, you will see an office hour that's a bit different. And that office hour is going to be for capstone project discussion. So everyone of that going through the whole course with me, by the end of the course, will build a bit bigger project of their choice. So, for example, you would like to create, I don't know, an app that classifies a type of a mobile phone, or you would like to create an app that, I don't know, uploads an image and from that image extracts all the colors. Anything that you would like, all of those will be in your portfolio. And the last session of the whole course, for now it's week 12. It might be week 10 or 12 depending on the changes in curriculum. But the last session is going to be you presenting for all of us your capstone projects. Obviously, if you are okay with it, you don't have to present it, but it's going to be fun. I won't do anything that last session. I will speak about like pros and cons of each of projects, but you will have really good project by the end of, obviously, if you dedicate your time. So do you have any questions so far before we move to actually part of Python? Nice. Cool. You don't have to wait for me to ask if there are any questions. You just prompt a question, and if my questions are right here, so camera is there, my questions are right here. So if you have any questions, I will definitely go and jump on the questions right as I finish with a certain part. Okay, cool. So I mentioned previously, as somebody asked about VS Code as an environment for as an IDE. So here, when you open the link from Notion for the first lecture, you will have all these links that will prompt you to install Anaconda. So let's go to Anaconda to see what it actually is. Okay, so previously I mentioned why Python is this amazing language that everybody speaks about when we mention data science, and that's the tools, or I would say libraries that support the ecosystem of Python. So Python as itself, you will see, is great programming language, but it does not provide you a lot of like functionality that you can build, I don't know, crazy products. You potentially could, but it will take you a lot of time and it will be slow. Anaconda is just like a package of all those of libraries necessary for data science or machine learning or any type of development with Python, like web development and stuff like that. So when you install Anaconda, Anaconda will definitely pick all those necessary packages. You will need to install some of them in the future, but by default, it will install all necessary ones for you. And you will just can start Python that comes with Anaconda and play with it. The different option, if you are more hardcore, is to install Python by itself. So you can install with this python.org, go download Python, and that's it. You're good to go. However, that requires for all of you to install those packages manually, which is fine. Like I done both things, but it takes time. If you are more on a easy side of things, install Anaconda. I'm always using Anaconda these days. It will take you more space. I don't know how much space you have locally, but it will take you about 2 to 3 gigabytes. And you have tutorials right here for Windows 11, Linux, and macOS. So whatever operating system you have, there is an Anaconda version for you. and you can go and install right here. It won't be necessary for you to install those packages for this course. So you can start following from to date until the last day with all the projects and stuff like that. Even the capstone project, you don't have to install anything locally. Okay. So what is this environment that I'm currently using? It's called Google Colab. And it comes with your Google account. When you have a Gmail, you can go and create, let me go to Google Colab. Okay, when you Google Colab without a V at the end, it will welcome you to collaboratory tool, and it will prompt you to create some like IPython notebooks or general notebooks. If you never worked with Python and you don't know what a notebook is, no worry, I will explain in a second. But here you can create a new notebook, which will basically create a new environment, a working environment that looks really similar to the one that you saw, but without any code in it. So this is basically how you start your working process here. Yeah, this session will be recorded and you can access it through a Twitch. I don't know how long. So for the last session, it is about 7 days. I hope we find a solution to stay forever uploaded. If not, I'll find a way to download this and upload somewhere else. But yeah, there will be recording of these sessions. Okay. So once you're here, you will be basically prompted with a cell that you can write certain things. And that's basically the environment that we have. So let's go back to my environment right here and actually see what we have. Okay, when you are here, you have this button connect. When you connect it, it will allocate a space and the processor and potentially GPU for you to work in the cloud. And just remember, everything that we are currently doing is completely for free. The only thing that you need to have is Google account, Gmail. That's it. And you can create these from like your Drive. You can create as like Googling, just Google Collaboratory or Google Colab, and the first link will be there. Once you're connected, you will see here stats that we have 13 gigabytes of RAM, and we have about 100 gigabytes of storage space. There is nothing allocating like how many CPUs and stuff like that we have, but I think it's generally like one CPU or 4 threads or stuff like that. If you need a GPU, like for this session we don't need, but sometimes in the future we'll start training more advanced neural networks. You can go to Edit, Notebook Settings, and here you can see Hardware Accelerator. For now it's none, so it's basically using CPU. If you go and select here, you can, from the drop-down menu, you can select GPU or TPU. So GPU is basically like any GPU that they support. Like I think it's T4, but I think it's randomly given to you. You can even select TPU, but TPU is paid. So bear with me, like if you use TPU, you have only 1 hour to use it. You don't have to remember it right now, but I wouldn't suggest with TPU. Go with GPU if you need any accelerator for your session. If you don't, go with none, and that's it. So this is how to set up like more advanced version of your Google Colab environment, and that's it. Okay. So let's jump to Python and start programming with the Python. The first thing that we need to learn, obviously with any programming language, is how to write hello world. And in Python, there is a function called print. And you just write print, and in brackets, you will be able to write a string. We'll talk about strings in a bit, that you would like to print on a screen. So for this is hello world. I will not go into details on how is everything happening in the background, because this is for developers. So if you're never worked with any programming language, this might be a bit too advanced for you, as I stated a couple of times in the mails. So here we are just learning what is the version that you already know from other programming languages in Python. Okay, so hello world. Basically, right now we have this the sentence saying hello world. And if you would like to print that in, I don't know, other languages such as Java or C++, this might take you a lot longer to write. And here, you can, if you want to add more code, this is for Google Colab only, you can put between these cells and it will prompt you with a pop-up code or text. You go code, you can go multiple times, and here you can write your code. It's multi-line cell, so you can write multiple times, and if you execute something that's not Python, it will say, hey, I don't understand what's happening right now. Okay, sometimes we would like to write different things together. Let's say I would like to write hello and then Luca, for example. So if I go like this, it will put together these two strings and write hello Luca. There are more spaces than we need, but you get a gist. So I can delete spaces right here, and let's see what's happening now. Okay, cool. So right now you see one pattern right here. When you just list whatever you would like to print together, let's say third item, it will print together and immediately add space right here. So if you were in Java or C++ or something like that, if you would like to print multiple things together, you would need to use a for loop, for example. We're going to discuss for loops in Python today in a bit. But you would need to print like one after the other and so on. Right here we have amazing, like a really easy way to do it, just with listing them together. And it will be really useful for you later on when you start debugging or printing like together whatever you would like to have and stuff like that. And right now, I wrote here hard-coded basically Luca. But what if I would like to have a variable that stores this information for me? So let's say name, and then I write Luca, and then I use this name instead of my string. So let's try that. If I go here, let's put more spaces here. I can go print hello and then name. If I do this, it will have the same result. And basically this allows us to combine anything that you like. So let's try to do this with numbers, and then we'll speak about variable types and stuff like that in Python in a bit. So if I try to do age and then put 26, for example, and then put print hello age, it will work. But what if I do like this? It will say, okay, I can do this between strings and integers. So what's happening right now? Here, this plus is basically happening in the background that you can have the same output right here. So if I do plus name, you will see that hello Luca is working, but it does not have any space. So in the background, what's happening actually is it uses this plus to put everything together, but it actually uses the space in between, so you will get the output like that. Okay, now you got the gist of storing something into variables. So we have a name, that's a string, and you got an age, that's a number. In the other programming languages, in that that worked potentially different. So if you're coming from, I don't know, Java, if you would like to store something in as an integer, you would need to write like this. But in Python, you're not going to do that. In Python, it's automatically determined what is the type of your variable by actually the variable value. So, okay, if I go and ask, you don't have to remember this type right now, of age, in the background, it immediately determined that it's going to be int. Okay, so this is something that you need to get used to, because you don't have to specify which type of variable you are going to use. So if we are going to say x is 515, y is hello world, as we used, and then z is 3.14, all of these works. And if you check the type of x, it's going to be integer. If you check type for y, it's going to be string, and same for z, it's going to be float. So you can check if you would like to check for z, you can go type like this, z, and it's going to show you that it's going to be a float. Okay. Am I going too fast? Do I need to slow down? Do you have any questions? Okay. So in Python, as in any programming language, you have, okay, cool. In Python, as any programming language, you have many different types that are pretty much, I would say, default in a sense. So you have integer that we already saw. Those are going to be normal numbers, like anything from 1 to, I don't know how much, 2.6 billion. Everything is going to be an integer. There is no big int here in Python. There is a way to do it, but it's a bit down the road. I don't know if we are going to need it at all. Then you have a floating point numbers, as we saw, 3.13. So anything that has decimal points is going to be a float. Then you have a bool. Bool is going to be a true or false. So basically, if you use true or false, well, that's going to be bool. And then you have string that we already saw. So any sentence, anything like with text, so any text is considered a string. And like in Java or like in C++, it's going to be string as well. And in Python as well, it's going to be a sequence of characters, a list of characters. And that leads us to the next point, which is list. So list, you have a list as a variable type, which basically consists of a subset or set of any item. We're going to speak about list. Lists are going to really surprise you if you worked from with the different programming languages, because here we can combine any type. Bit precision for, yeah, a 64 I think are by default. You can convert them to a float 32 or for, yeah, float 16 as well, but you need to do that explicitly. We are going to do that later today. But yeah, by default or 64. Okay, then you have a tuple. Tuple we are going to discuss in a bit, so just remember that there is tuple for now, but we are going to speak about difference from a list and tuple in about 30 minutes. And then you have a dictionary. So if you work with other programming languages, this is going to be a key value pair or a map, hash map, stuff like that, where you can access your value by referring to the name of it and stuff like that. Is going to be really useful for data science. So there are so many projects out there that are going to be crucial, or not crucial, but really easily solved with dict structures instead of anything else. Okay. So previously we saw that when I wanted to do hello plus age, we saw an error. that said, okay, so you can't concatenate a string with an integer, but I really want to do it. Like, I really want to say hello 26. Why this Python does not allow me? So there are ways to do it. Like, if you would really, really like to print it together, you can by using casting. So casting allows you to convert from one type to another with a bit of a consequences in some cases. So we are going to cover them as well. So if I would like to keep it integer, it's a still integer, it's stupid for me, but let's try. It will throw the same error, but we are making sure that's an integer. We don't know if it's an integer, but we are making sure that's it. But if I want this to work, it's hello. Let's put string. CTR is shorter for string, so you're not going to use like this. Okay. And right now this works. I solved the problem. I'm having hello 26. I'm really happy. So sometimes you would need to make sure that this like output from anything or the value of your string is certain type. So for example, sometimes you would like your front end to allow user to enter the age or the name or I don't know, the bank account. You don't want really to have, I don't know, a string in the bank account number. You would like to have numbers or a phone number or anything like that. This casting is really coming in handy when you would like to solve those problems. Sometimes in data science, you have a data set of like a table of information. Let's say we have, I don't know, a table looking like this. ID, then we have, so let me actually mark it like a comment. ID, age, name, then we have potentially gender, maybe something else, doesn't matter. So you have like for each user, you have this information. And you get this information from your client and say, hey, I would like to predict for you to predict or just classify or cluster my users in a way that I can create a better marketing strategies. Amazing, so let's do it. And then you put it through algorithm and okay, this is a breaking point because age is not a number, it's a string. So what you're going to do, you are going to put every single age information through a casting that's saying, okay, I don't want you to be string, I want you to be integer. Okay, so basically that's how you're going to do. You can do it in many different ways. So let me show you, for example, the consequences. If we have a floating number, let's say 3.14, and then if I print it like FP, I'm going to have that. But then if you're going to print again integer version of FP, well, then you're going to have an issue. What if you would like to have a 4 instead of 3? There are libraries that are going to help us with this, like Math, like and NumPy. We're going to discuss them today even. But this is something that you might like miss in your program and stuff like that. So I generally missed it a couple of times, and it's a stupid error, small error, but it makes a crucial thing when you have like 10,000 lines of code that you don't know that this small bug is causing everything to clash. But it happens, so you need to make sure that everything is okay. You can also convert it back to float, like with float and stuff like that. And like I told you that you have bool, for example. So if you have, I don't know, is user, for example, variable that said true, and if you print it to true, then it's going to state it's true as we expected it to say. But then if you convert it to, for example, integer, then you're going to get 1. So in basically any programming language, 1 is true, 0 is false. And if you want to check whether or not this, I don't know, this variable is user equal to 1 instead of equal to true, you can by converting it with int. Okay. So this is basically it. That, yeah, okay, I went a bit faster, so here are the mistakes that I already covered. So basically, you need to make sure that if you would like to have a certain like number, and sometimes just like I mentioned, for example, if you have a num that is 5.8, and if you convert it to int, you would expect to be 6 because it's closer, but that's not how it works. So in when using casting in Python, it will always cast it to the first number. So in this case 5, so it removes everything after the decimal point. So even if you had 99, so it's basically 6, it's going to be 5. So you need to be careful with that, because if you use NumPy or some other packages, when you have 051, this is going to be sealed, which is basically 6. But in this case, when you use native Python, it's going to be 5. So be careful with that. Okay. Then I need to introduce 2 more concepts that are going to be really useful for us, and those are list and tuples. So as the name suggests, list, xlist, for example, is a list of numbers that are 1, 2, 3, and so on. And if I print xlist, it's going to have these, I don't know what is the name of these brackets, but these brackets. But yeah, the difference between lists and tuples are subtle but important. So lists are changeable or mutable, and tuples are immutable. When we create a tuple, and let me show you that, if I create a tuple, as the same as the list, and print x tuple, it will work, and it's fine. Like it's basically that. But in Python, it allows you to, like, for example, change a certain item. And let's say we made a mistake and you'd like to change the first item of a list, so this one. So if I use xlist of 0 is equal to 5, and then let's print xlist again, you can see that I changed like the first item. Don't worry, you don't have to remember everything that we are discussing today. We're going to have more lectures on that list and stuff like that. We're going to explore like what this means today. But yeah, just showing you to get a feel what errors might happen when you work with data in Python. If I do the same things with a tuple, and say, okay, I like to change this, it will throw an error. And it says object does not support item assignment. Because we said, okay, it's a tuple and I'm okay with this having 3 items. Those are items 1, 2, and 3. And that's it. You cannot change it. So for example, when you want security, like I don't want anybody to change the information about my users, you're not going to use lists, you're going to use tuples, for example. Those are subtle changes. Obviously there are more, but for now, that's just important for you to remember. You can cast between them too. For example, if you would like to change tuple, there is a way, and you can say, okay, x tuple list of x tuple, and that's going to convert it to your list, and then you can say number of like the first item is going to be 5. So basically we trick the system. So Python is not perfect, but basically we were able to convert tuple to a list and then change the item, like the first item to 5 that we initially wanted to. Okay. Do you have, is everything clear so far? Do you have any questions that came up to your mind so by now? Okay. Okay, cool. Just a few more examples of casting, and then we are going to jump to arithmetics. So in Python, you can basically use, let's say, I have, if I had a number, num1 is equal to 5 and num2 is equal to 2, and then I would like to, I don't know, divide them and say result is equal to num1 divided by num2, and then print it out, we're going to get actually 2.5. But you're working with integers. You can convert the result right here. So you can convert the whole operation together and then let it be. Or you can use and convert res into integer as we did previously. So sometimes you had the operations like, for example, dividing a few numbers, checking whether or not like there are more items in the list or stuff like that. So that's no common thing to do when you're working with data. These are the types of checks that you are going to do. So, hey, I would like to check whether or not this is an integer. Like I would like to know that. And I mentioned this previously. Sometimes I want to say age user input, enter your age. So in Python, it's really easy to take user's input. So enter your age, and then it will prompt user to enter their age in this case. And let's see what happens. When I enter my age, let's say 27 now, and I'm fine, it works. But let's check the type of my age user. Is a string. So, but what if I want to check if a user is above 18 for my website to work? I can't check it with integer, so I need to convert it. Age user int, for example, is int of age user. And then let's check it again. Now it works. And if you want to check if that's the same and correct number, it's 27. So sometimes you would like to make sure that whatever user provides to us, it will stay as it is. Just be careful, as we are speaking about errors and stuff like that commonly happen in Python. Sometimes you would like to say integer of name, and this will provide an error because Python cannot do it. So Python is, I would say, smart enough. So it says, hey, this is a string or whatever, some other thing. Please don't put this inside int. You can't work. It can work. Okay. So operations in Python. Operators in general, when we speak about, there are two types: arithmetic operators that will help us to work with numbers, see whether or not there are more items in a list and stuff like that. And there are comparison operators. So you're comparing two variables together, two values together, whether or not they're equal, less equal, and stuff like that. So let's start with these simple ones. So you have plus. So if we have num1 is equal to 5, and num2 is equal to num2, we already work with plus and division as well. So we had num1 plus num2 is equal to 7. Then if you would like to divide them, you have num1 divided by num2. You will get 2.5. Obviously, the same applies. Let's copy and paste it a couple more times. So we are just changing the variable, the arithmetic itself. So we can subtract. You can divide. And you can actually do the exponent, for example. So 2 exponents are 2 multiplications, and one of the stars is just 1 multiplication. So let's see what's happening right now. So we got like 7, we got 2.5, 3. Oh, we divided 2 times. That's fine. We can use floor division, which is going to be 2, and stuff like that. So all of these operators, can be applied to basically any number that you have. Like it can be an integer, it can be a floating number, and so on. And you're going to use that in the different scenarios depending on your needs. So for example, modules, you would like to check whether or not, I don't know, when I divide a counter of a for loop by a certain, like for example 2, and every second number will be like 0 because there is no remainder of division. So we can say, okay, just print every second number or stuff like that. Oh yeah, you can access it right now. So if you go to our Notion site that the link that I provided in our Discord, you can go to the first lecture right here, the week 1. Yeah, thank you. So yeah, basically you can do from here. You can make a copy on your account and you can start changing it whatever you like. Like there are no limitations when you make a copy. You can change anything from text to whatever. Cool. Okay, as we had arithmetic operators, we have comparison operators. So basically works with the same goal to do some operations. In this case, it's not like changing the original numbers, but comparing them. So the first one, you're basically saying, okay, is this equal to another number? Is this not equal to, greater or less, and so on. So basic mathematical operators. And you can say num1, for example, here, or let's say x is equal to 10 and y is equal to 10 as well. And if I say x is equal to y, this should yield a boolean, which is true. Okay. Then another interesting thing, because we said true is equal to 1, I can compare it to 1, and this is equal to true as well. So let's comment this out. As you can see, if I ask is a false equal to 1, obviously it's a false because this is equal to 0. So we've spoken about like different conversion from boolean to integer. So false is always 0, true is always 1. And if you compare them with the real numbers, integers, that's going to be equal to true or false, depending on what you compare to. This is going to be helpful when you make more complex rules down the line, when you're making functions and stuff like that. Okay. So as we have right here, you can have different operators like less than or equal to or not equal to. So for example, if we go and say x is not equal to y, this is going to be false because it's equal to. And you can ask whether or not this is bigger, or like if this is bigger, it's obviously false, but you can add a check and say larger or bigger than and then equal to. This is going to yield with a result of true because there is a equal sign operator behind it. as well. Okay, so you can do these checks, and this will definitely help us when we start introducing program control flows, like if statements, while, and stuff like that. And right now we asked like simple yes or no results, but then you can combine multiple. Like you can say, okay, let's say I have x is equal to 5, y is equal to 10, and z is equal to 5 as well. So let's make a bit complicated one. So let's say, is x equal to 5? To y? Obviously the answer will be false. But then I want to ask or x is equal to z. And this will provide us with the argument of truth. So what happened here? Well, basically we said, okay, I don't care if both of them are correct. I want only one, at least one, to be correct. And that will yield with the overall result. So in this case, the first one failed. We said, is x equal to y? Obviously that was not the case because y is 10. Then we moved to the second one. The second question said, hey, is x equal to z? In this case it was. Then you can go and check something like this, and obviously it will still be true because we are still asking whether or not this or this is correct. But then let's ask with AND question. And this should ask whether or not both of them are correct. So first it will ask the left side and say, hey, is x different than y? Yeah, it is, because x is 5 and y is 10. And then we already know this is correct. But then if only one fails and say, let's ask like this, it will be false. So the first one passed because they are obviously correct, different ones, but then because these are two equal values, 5 and 5, this was false, which actually created a false statement for the whole expression. Okay, this by itself is really important for us in the next section, control flows. So all of the things that we just did are really basic, but the fundamental stuff, so we can build on top of them. So I'm just using building blocks to build something more complex. The next complex thing for us is control flows. When you're building a program, you don't really want to execute everything every time. Sometimes you would like to execute one part of the code if something is passed, if something is correct. And then you would do the same thing if that's not correct. So you have if statements. If statements are present in almost every programming language that are used today. So if you used any programming language so far, except maybe HTML, pure HTML, you have if statement. You potentially saw it somewhere. So let's say, I don't know, material is equal to 100. House requirement is equal 1000. And I would like to ask a program, let's say a robot, it's a stupid example, but let's do it, to print me whether or not I can build a house. And it's simple. So we already know how to compare two variables with our logical operators and conditional comparison operators. So you can ask, okay, do I have our materials bigger or equal to house requirements? If that is correct, I'm going to print build that house. If that's not correct, let's execute another code which state, oops, earn more money. And the result is obvious. We need to earn more money so we can build this house. But if I had earned that money, I'm going to build a house. So basically, it will ask the question, and if this is true, it will pass to this part of the program. If that's not correct, we'll pass to the second part of the program where, unfortunately, we don't have enough money. Let's work harder and earn that money in the next couple of months and then build the house. Okay? So this is really useful for data science, for anything basically that you do, no matter if you're a web developer, a data science, machine learning engineer, or whatever. So sometimes you would like to check quality of variables, which we are going to do a lot. So you would like to check whether or not certain variables are above threshold or around mean, standard deviation, what is the standard deviation, stuff like that. So we are going to use all of those operators to check whether or not our user needs to work harder on collecting that data or not. Okay, cool. But there is additional thing. So for now, we used if and else. Let's copy this and paste it right here. And sometimes you want to have more cases. Like what if we are like so close on building a smaller house? So we don't have for $1,000, but we have maybe $500, and you want to execute that part of code when you are for a smaller house. So if materials are bigger than or equal to 500, for example, or let's store that to another variable and call it small house 500, then I'm going to put that variable right here and build that small house. If that's the case, okay, this actually executed both of them. So what happened? What is my mistake? Well, it first checked that out, and said, okay, this did not have any other failing case, and then it entered this part. So how to connect these two parts? Well, it's really easy to put, instead of if here, else or else if. So in other programming languages, it's going to be like this. This does not work in Python. So in Python, it's elif. So if the first one is incorrect, it will jump to this part of the code and say, hey, does this work? Do you have enough money at least for a small house? And it will say, sure, I do, or I don't. Then, yeah, we need to earn more money. So if I execute this, we have 1,000, which we stated right here. We're going to solve the first case and don't watch anything else. But if I change materials to maybe 600, we don't have enough for the first house. But if I execute, if I execute this, it will say, oh, build that small house, because we have enough materials suddenly to build another house. Okay, we are more than an hour. I would make a small break right here to have any questions, and if you want to go to toilets and stuff like that, like 5 to 10 minutes, if that's okay with you, and then we can continue with for loops and other parts of Python. How does that sound? Cool. Thank you, guys. So I'll mute myself, and I'm here. See you in then 5 minutes. So yeah, we are not going to start for just a couple of minutes because people are just coming back and stuff like that. So relax. Um, like if you have any just general questions about the course, you would like to discuss like about certain stuff that we are going to do, we can do that now. We can do that later after we finish with the Python. So yeah, what are your expectations? What would you like to do? Why are you here? I would like to know that as well. Nice. We'll definitely do some cool projects. Cool. Okay. Are we okay to continue, or do you want guys to wait for a couple of more minutes? Okay. So, okay, cool. So far, let me switch to code. Okay. So far, we talked about uh, like conditionals and how to control the flow through the program. Like sometimes, as we discovered, like we would like to think about or execute certain part of the code. Sometimes you would like to uh, just don't execute anything. Like for example, if you don't have enough users, you're not going to perform recommendations, or like stupid example, but sometimes uh, that might be the reason. Um, but then, like, imagine that once certain stuff happens, or you need to execute certain operation multiple times. Like, imagine that you need to write "Hello World" um, 10 times. So one way is basically do this. Oops, that won't work, but this, like this. Is this good experience? Is this good code? Obviously not, but it will work. Yeah, there are other ways to do this, and I I would never suggest doing this. But yeah, so let's say we would like to write this hello world for 10 times. And to do that, you can go and say for then some item, for example, and in, and then Python has a function called range that you can put a number in, and then two dots. So far, we executed mostly. You saw these things right here, which is called indentation, but we didn't talk about them yet. So if I execute the code right here, it will break because it does like this. A program does not know whether or not it should be a part of for, or it's just individual thing that we just wanted to have there. If you would like to repeat this for 10 times, you need to tab it in or to indent it. So Python knows that it's a part of for loop. A quick note on the side, one of the largest number of errors when you're working with Python is those indentations, especially when you copy one code from one place to another, or download something from, I don't know, Stack Overflow maybe. Then you paste it in your code and bam, does not work. It happens a lot of times. So when you execute the code, if you're recognizing this as an error, that's basically it. Some pieces of your code are not properly indented, sorry. So it won't work as a Python, so it will break. And here it is. I printed out for 10 times. So what happens right here? Let's break down each of the parts. Range is a really useful function in Python. And this introduces us to, like, we used int, we used float, we used those casting functions so far, but they are really there. Like, they have this main functionality, which is casting from one type to another, and that's basically it. Python, one of the reasons it's like a so user-friendly language, it actually has some built-in functions that are specific and solves a specific problem, so we don't have to code it ourselves. So range is one of those functions, and you can say range, and then it will show this documentation, which we didn't show so far. When you have multiple inputs to the function, we'll talk about functions in about 15 minutes, maybe less, you will have a documentation stating what is the input to the function, what are the arguments. And I'm giving you keywords right now so you understand what is the wording used when you discuss with a Python developer or a developer in general. So here you can state, okay, I want just 10. And if I execute like this, it will show a range. It does not give us anything that we recognize so far. But luckily for us, we have one casting function that can help us understand what's actually happening under the hood, which is list. So list allowed us to convert this range into a list of numbers. And right here, we understand what happened in the background. Range is actually creating a list or a sequence of numbers starting from 0 by default and ending one number before the number that we stated. So it's not including 10 because we said 10, it's all up to 9. So if we say 20, we'll have all numbers from 0 to 20, not including 20, okay? But then you can change that. Like, imagine that you don't want to start from 0, you want to start from 5. And this makes your function or range more complicated, but still more robust because it allows you for more cases. So you can say, hi, I want to start from 5 and then end by 10. Sure, I can do that for you. But then I'm still not including 10. I'm including 5 and up to 9. You can obviously go up to 11, which will end up including 10 because the same rule applies. It's not including the last number that you stated. Okay, cool. So what the range can do for us more than this? And there are more things. So you can start from 0. Let's put it here as a default. And I don't want to go from every number. I like to do the every second number. So you can do that. You can specify that easily with a third argument saying I want a step of this range to be 2. So I'm going from 0, 2, 4, 6, 8, and because I'm not including 10, I'm stopping by the 8. You can change this 2 easily to 3, and then I'll have these numbers, and so on. Does it make sense? Okay. So range is really useful when you want to create a set of numbers, thing that you would like to iterate through and stuff like that, or you just need a set of, like, a data set. Like, the simplest way to generate data set is with a range. It's a stupid data set, but it can be done. So let's go back to our for. So if you go to this explanation that I provided here, you're going to for I, and this I is an item. This item here in is always there. Sequence, and in this case that sequence is generated with this range, and we now know that the range starts from 0 and goes all up to 10, excluding 10. We saw this through this example right here. So instead of printing hello world, let's change and print I. to see whether or not that's the case. And as you can see here, it is. So we basically put it right here, print I, and it's going to print every time. You can basically apply the same things and say, I want to start from 0 to 10, and then every second number, which is going to be the case as well, and it's going to print only 2 every second number. Okay. So the for loop is there. If you would like to go through set of items, you would like to check whether or not a certain item has a specific value or stuff like that. For now, we use this built-in range function. In most cases, you're going to use this range to generate these for loop statements. Okay. Okay, so the negative step, okay, cool. Let me explain that. If I go like this, it will not print anything. But if I go and -1, if the first one, which is a starting point for a range, is larger than our second, which is the ending point, then it will not work, except we set up the negative number right here, which says, okay, I want you in the reverse. So you can reverse the range. If you want to go through from the largest to the smallest, you can do it as well. But if you go by default, let's go and change this back to our previous case, say like this. It will still work, but, but it will be confused and say, oh, okay, this does not make any sense. Your code will not break. That's the issue, I would say, because if you made a mistake and instead of, let's say 2, you wanted 2, you clicked and put -2 because you thought about something, your code will not yell at you. It will basically execute normally, but the logic under the for loop will not execute as well. So that's kind of a tricky situation to be, because like you don't have an error, like that's compiler detected, but you still have an error because this part of code that you wanted to execute, it's not executing. Okay, so that can happen easily, and let me show you direct example how that can happen. Let's say I have this for loop which goes normally through the list of numbers from 0 to 10, and then I made a copy, and I was talking to you right now, and I just put -2 because I know that -2 is the step that I will take, because I want from 8 to go back to 0. And I did execute that and I made a mistake, because I forgot to change the order of these two numbers. That can happen all the time. I know that like a lot of like people in the interviews, when they're interviewing for Python developer position, stuff like that, making these mistakes because they are like concentrated on the problem and stuff like that, and they are not thinking about reordering these two arguments, which is a simple mistake, but still a mistake that can cause you a working algorithm for your interview. Okay. So additional thing that is really useful for us when you have a for loop, sometimes you don't want to use range. You have let's say a list. So I will still keep really simple lists, like L1 list, and you don't have to use keyword list. You can use like these brackets and start listing numbers, and let's say like this 511, 3, 33, 44, and stuff like that. And that's my list. I don't want just more complex list for now, and I would like to print out every element from this list individually. So you can go for item in L1 and then print item. Okay, so I did two new things right here. The first, I renamed this I to item. You can do this and rename it to whatever you want. You can rename it to nothing. You can rename it to, I don't know what I'm doing, stuff like that. Or you can keep item or I, stuff like that. So it doesn't matter. It's for your program. In generally good practice or Pythonic practice, if you're just iterating and not working with this item, it's going to be I, K, J, and stuff like that. And nobody from your team will yell at you because you use that simple variable name such as I or J or whatever. But when you're iterating for a list, such as this one, and you want to do something with that list, let's imagine that these are IDs of users. I don't want you to put just I want to know what's this item about. Like, I want to know that it's ID of user. Okay? I want you to put specific things that you're going to work with. That's a good practice when you're working with Python. Throughout the course, we are going to introduce these small nuances and things that are going to make you better programmer in Python as well. So no worries for now about that. The other thing that I did here, camel case is not generally used in Python. It's underscore or snake case. So basically you use ID underscore user as a name of the variable, and that's it. So what I did here, I first properly named it. Instead of range, I put right here a list called L1. So by the way, L1 is not a good name for a list. If these are IDs, I would like to know that these are user IDs taken from the database or stuff like that. And then I'm just printing that user ID. Here we go. So you don't have to use range. Anything that's a sequence based in Python can be iterated through. So Python allows us to have those iterable items or variables such as lists, tuples, and stuff like that, that allows us to create these for loops or while loops around them to print them out. Okay? Cool. Then we can switch to a while loop. While loop basically has the same goal as a for loop. So you're going to iterate through a set of things, but then you would like to have a condition right now, which as when it fails, is going to be basically the signal to the code that we need to break out from this while statement. So how to do it? And I'll do two simple examples and you will understand what is the difference and some use cases where you would go with while over for loop. So let's say that I have a variable called I is equal to 0. And I have this variable, which in this case of the first for loop, we just put I here as a counter. And I would like to replicate this but in a while loop. So we know that it should print out all the numbers from 0 to 10, or not including 10, but in a while. Okay, so the condition is while some condition. Okay, condition. Then here I'm going to print I, and obviously this is going to break because I don't know what is this condition. This I is 0. Am I like increasing the value of I or not? So we don't know. So first condition is if I is equal to 10, less than or equal to 10, then we are going to go through while. So as long as this is correct, we are going to iterate through the loop. So we are starting from 0. And if I just execute this, because I will always be 0, this will run forever. And it will potentially break your computer. Not really, but it will definitely use a lot of your RAM. It happens to me. I was concatenating something to a text file when I started programming, like back in like 2011, 12. And I forgot to go out from the while loop, and I made a text file with the size of 4 to 5 gigabytes. It broke the computer. So we need to increase the value of I. So I did one more new thing here. So I have an I. Instead, this is the same as I would if I go I is equal to I plus 1. Basically the same. So I'm taking the I, the value of I, and adding 1. So because I is 0, I'm saying 0 plus 1, override the I, is going to be 1. So I'm doing the same here, but instead of doing this, I'm putting it more like dense and going to put plus equal to 1. And if I just execute, I'm going to have the same thing right now. But then we have an interesting thing here. Instead of going from 0 to 9, it will print all the way to 10, including 10. So what is the difference? Difference between for loop and while loop in the way of execution is here, for loop goes and say, okay, do I have more items? If I don't go inside of for loop, just exit. And until that happens, go through for loop and do your stuff inside of it. But in a while, it's not the case. In a while, it will check and say, oh, is this correct? Yeah, it is. Is this correct? Yeah, it is, and so on, until the one moment it's not correct. When that case is happening, it will still enter inside the for loop, execute one more time, and then exit the for loop. And sometimes you will have that behavior, like when you go in, when you don't have any more items, and you try to execute and you make a mistake. So you basically want to do like this, and it will work. Okay. So that's basically a while, how to write the same thing as we did with a for, but with a while. It's more complicated, but then sometimes it has its purpose. So let's see another case. Let's say that you have a simple function that is running on your program and waiting for a file to arrive from a user, like uploaded file. You are writing a really crazy simple function in Python, which constantly checks the folder and say, hey, do I have that file? Do I have that file? Do I have that file? And so on. Once the file is reached, I can break out from the program, process it, make a prediction, send it to user, and so on. But then I need to constantly check. Obviously, you can time it, so on, but let's say we would like to constantly check it. So I can simply write true here, and then it will run forever. There is no additional catch or a question that needs to be asked here. We are still running forever. And if I execute this, it will increase I to plus 2 billion if possible. And obviously I will not execute the code because I don't want my session to be overridden. But yeah. So how to execute this? And this by itself, let's comment this out so we are not making this mistake. Let's first copy, comment, and so on. Okay, so to have this statement break or exit itself, once we have that file uploaded, we need one more thing. We need something called break. As you can see here, we have two options, break and continue. Break will basically exit the loop early. When something happens, it will just stop iterating whatever is the loop, either for or while. Continue is going to skip that iteration and go back to the beginning of the loop and continue. It sounds a bit interesting, and yeah, over there, let's see how to work with it. So let's say that our trigger, that file was uploaded, is when I becomes 10. So if I say I is equal to 10, break. So here, what happens is it will go do its job and so on. Once it becomes equal to 10, it will pop out from while, and as you can see, we got the same result as before. So that's basically break. So you can break out early, so you don't have to wait forever. We just got the file immediately. Sometimes, let's go with the 4. I would like to skip iteration. Let's say that you have, I don't know, different file sizes or different extension of files in your folder, and every second file for some reason is CSV, but you only want Excel files. So if you go and ask if I is divisible by 2 and module, so we don't have anything left after dividing by 2, continue. Otherwise, print I. So what will happen, once this happens, it will just continue with iteration and don't care. But sometimes when it's like not the case, it will like basically go to this else statement. So personally, I almost never use continue. So I'm almost sure that for anything that you're going to build in this course, you will not use continue. Break, definitely, many times. And break is really, really simple to use and integrate in your programs, and making sure that you are going to end up with the same result as always. Okay, so now I'm going to dig deeper into lists and tuples. So far we talked about lists and tuples for multiple times, but we never actually entered and talked about what operations and what is so unique about Python lists, for example, that we can do. Okay, so let's say I'll copy one list that I have prepared, so we don't have to write it twice. It's called fruits. So in this list, I have apple, banana, orange. And this is our list that we are going to work with. As I mentioned before, as a range function, for example, the Python has, for each of the types, different functions that we can perform on top of it. So when I do this, we already saw, for example, that you can do something like this, fruits of 0. And this is a simple accessing of items in a Python list, where you have like 0. Let me. This is the 0 item. This is 1, and this is 2. So if you use fruits of 1, it will print out banana. If you use fruits of 2, it will print orange, and so on. So it's always starting from 0. Don't make that mistake. It always starts from 0. So if you would like to print only for example, the first item, as we did, is going to be accessed with 0. If you want to print orange, the third item is always ID minus 1. So it's 2 in this case. Okay, great. But imagine that my wife gave me this list, and suddenly, like, she texted me and said, "Oh, but you don't need bananas. I would like mango." Okay, I said, okay, great. I don't need bananas, but I need mango. Great. So one way is basically just to add mango at the end. But then we still have banana, you know? So we need a way to either override banana, delete banana, stuff like that. There are two ways that we can do this, and I'm going to show you both. So the first way is I can say, let's make fruits of 1, so that's banana, is equal to mango. Okay, and print fruits. As you can see, we changed the value of the first element, or sorry, the second element with the ID of 1 to mango. And now I have a properly updated list that my wife wants me to buy. So I have apple, I have mango, orange, and so on. Okay, so this is basically the way that you can override the value at certain ID and change it. So, but that's great, and obviously, as like already again, I know that's going to happen. But my wife called me again in the middle of a shop and said, "Hey, I really don't want mango. I only want apple, oranges. You don't need bananas. I bought bananas, so you just need to go and buy apples and oranges." I said, "Okay, sure, whatever." And I'm going to do fruits, remove, and then you're going to specify the value mango. Okay, and let's print fruits immediately. And as you can see, it found the place in the list that has that value. In this case, it's a mango, and it removed it. So right now I have a new list, all apple and orange. Okay. And I'm walking down the aisle and I suddenly see kiwis. And I said, okay, I like kiwis. I like to buy kiwis. So let's add it to my shopping list. So how to add it? So you can go and say fruits, append kiwi. And this, okay, I didn't write it correctly, so it will yell at me. Yeah. Okay. So I added kiwi twice. So I added kiwi twice, and I love kiwis. I don't know, but because I executed this line twice, so this is appending kiwi 2 times at the end of the list, and this is the behavior that you're going to see. Append works as a way that you're going to append by default at the end of the list. So you're basically going and like putting behind every single item. Okay. So right now you may ask, okay, but remove what? Right now you have 2 kiwis. So let's see what is the behavior of remove kiwi. 1 kiwi left, and that's great. Python understood that I just want to remove only 1 kiwi. Here you can see because we have 2 kiwis, but it's going to remove always the first item from the left. So the first item added, that's one that's going to be popped off. Okay, great. So we understood a couple of things that are important, like you can remove items, you can append items, add new items, remove items, and so on. I think I said the remove twice. You can change value of items and so on. But yeah, so you saw this that we said, okay, fruits of 2, fruits of 0, and stuff like that. That's called indexing. So we are using IDs of certain items to get value at those positions. And in Python, you can use some crazy things that are really useful. So let me add kiwi2 just to have more items, kiwi3 and stuff like that. Just to show you a couple of crazy things that you can do with lists. So if you want to execute access only, let's say kiwi at ID of 3, so it's kiwi2, you can do like this. But then I want only this part of lists. I want like ID 0, not 0, sorry, 2, 3, and 4. So one thing that you can do here is use this. I want this and this. And it's going to slice my list in a way that I'm just accessing these particular items. Okay, what happened here? Okay, so these dots point out to me that, hey, I'd like to get this ID and all after that. So if I change this 1 into 2 into 1, I should be able to go from ID 1 all up to the last item into the in the list, including this ID. Okay, so we know that this is 0, 1, 2, 3, and 4. Let's say I want all from orange to kiwi 2, but not including kiwi 3. So I don't want the last item. So let me go and say, okay, this is 0, 1, 2, 3, 4. So all up until 4. So now I sliced my list and said, okay, I want all from ID 1, including ID 1, all up until 4, ID 4, not including 4. Okay, does it make sense? Mm-hmm. Okay, pop is, okay, that's a great question. So let me add more cells. So if I go and call pop and then print fruits, what's going to happen? It's going to take the last item. So remove, you're going to specify a certain value and say I want like kiwi free, for example, to remove kiwi free. Pop is always going to take the last item added and then remove it. I think in the new version you can go and specify ID of item and say 2, and then you're going to remove kiwi, just kiwi. So pop will remove by default the last item if you don't specify anything in brackets. But if you go and specify the ID, it will remove that ID. Yeah. Great question. Thanks so much. Okay. So back to our indexing. Indexing is really important because that will help you a ton when you start working with like a couple of hundreds or thousands of samples. So I want to take all users from, I don't know, let's say 100 to 400. And it will take all users from in that range, and we will explore that in later lessons in the course. So right now, let me go back. So basically I took this. Okay, and somebody asked about errors. This is one more thing that it does not make an error, because like right now, because we used pop2, it does not have 5 elements. So the last one is kiwi 3, which is ID of 3. And if I use all from, let's say, 4, it takes all up until the last item. And I can use here 400 and I don't 4,000. I don't have 4,000 elements, but it will assume that it's going to be until the last element. Okay. Sometimes you don't know what is the list size. You don't know, like you are dynamically adding more and more items, and you just want to take every single item from second place to the last place. You can leave as it is, but like this, or you can use something smarter and use -1. -1 indicates the last element. So the last ID, okay? Sometimes you would, let's say, sometimes in the structure of the file, last couple of rows, as people wrote like entry points, put information such as either telephone number, a name of people who worked on a project, stuff like that. I saw many of those Excel files. You need to skip them because those are not relevant to your data set. Your data set is starting from ID of, let's say, -2. So I'm going to start from, this is -1, this is -2. And I'm taking like all up until that. So remember that the something that we are specifying right here is not included. So we took this item and all up until the -2. And we only have orange. Okay. There are more useful cases like skipping every second item, reversing the list, and stuff like that. But I will not introduce those concepts right now. We are going to work with them later in the course. Once we start working with those, we'll definitely mention and explain how those works. But for the first session, I think it's enough just to remember that this part of indexing, and there is a lot more that we are going to learn through next couple of sessions. Cool. So what's happening with tuple? So tuple, as we saw before, I can create a tuple, colors for example. I can access any of items the same way as we did, like colors for example, and say 0. And it will print out red for example. But if I want like this, it still works. So indexing works as it did for lists, but then all the things, for example, append, yellow, it will start yelling at us. I mentioned previously at the very start of the session that colors, or sorry, not colors, tuples are not changeable, so immutable. You end up with what you have. Sometimes, as said, you will start storing information about users or downloading the data from the net. You don't want to change it because that's a source of truth, for example. You are going to store that in tuples. You can always convert a tuple to list and start working with it. And that's kind of unlocks the ability for you to work with the data in a sense or change it. But if you just want to read it, it's fine to work with tuples because you're not going to change anything regarding the data. Okay. Basically that removing does not work as well because we are, as I said, with this, that's it. Changing the specific item as like green to yellow, as we tried before, does not work, and stuff like that. Okay. So far we explored a lot of things about Python. All of those are going to be enough for you to start working, create some scripts. But some scripts are going to be more complicated than others, and it will require you to write certain piece of code multiple times. Let's say calculate a square, or just print the name of a user, or call a function inside a function, stuff like that. So if you need to write, let's say, 10,000 users' names, that's going to be difficult. And if you want always to change the version of that name, that's going to be also like really repetitive as well. Yes, we talked about for loops, but we are going to be more advanced now, and in sense of providing more functionality around that. So for loops are just executing certain things multiple times, but then functions are there for you to abstract certain piece of code and say, okay, I'm going to call this 10,000 times, for example. So functions, as right now said, are blocks of code that allows you to abstract that piece of code and say, hey, I will take some inputs to that function, and I'm going to crunch the data, just print it out, return like square root of that number or whatever, and then basically that's my function. If you remember, we already worked with some of them, like for example range. That range is a function, but we didn't write it. Python has it by default. So who made the Python wrote that function. So each function has some inputs to it. Not necessarily, it's not required, but mostly it does. And basically you can put that data inside the function, and that's basically it. Okay, so let's see how that works in practice. The structure of function starts with def. Def is shorter for definition, so you're defining a function, then you're going to give a function a name, so some name, and then you're going to use these brackets, and again this it's not semicolon, I think it's semicolon, I forgot what is the name in English, but yeah, so you're going to use that, and inside the function, remember indentation that we talked about, you're going to use some functionality. Colon, thank you so much. Thank you so much. Okay, so you're going to print something like hello. Okay, and we wrote a function, but that nothing happens. Okay, cool. So I need to call this function. Calling the function comes like this. You are referring it by the name, so that's why we define the name, and we are putting these brackets. Let's call this, and we got the answer, hello. Okay, cool. So this is not really useful function because like it's just calling a print function, you know. So let's make it more advanced. Let's add a couple of more cells. Let's paste the same, and instead of some name, let's call it hey there. And right now I would like to introduce an argument. So the first one is called name, and here inside this print function I'm going to define a name. Okay, so here I can use this function as many times as I want, and I can say Luca. I'll explain what happens here in a second. I can say John, I can say Marco, and stuff like that. So I get the answer always calling the same function. So right now I never print hello plus a name, for example. I'm just calling this function hey there, and with the name of a user, for example, that I like to say greet when they enter a chatbot, for example, or I don't know, our front end. So that's basically the function in a nutshell. So here, instead of this name, this is our first argument, we are providing a value that's going to be represented inside this function. I can go more in details and say name is equal to Luca, because this is the name. And let me show you, the behavior is still the same, it's just, it's just the way that we're referring to a function. And if I don't have anything, let's say last name, it will yell at me because, hey, there is no argument with called a last name. So you need to make sure that you are referring this by whatever the information you put here. Then we talked about our like conversion and like, for example, casting and stuff like that. Okay, I just need to tell you, users are mean. User will tell you anything, will do anything to screw up your program. This is a really simple function. This just says hello and a name. And let's say instead of Marco, I'm putting my age, 515. And it will say, okay, so it works. So why does it work? Well, we are having a print instead of, and we are using this this comma. But then some programmers love to use plus instead of column because they are doing more operation instead of just like printing out, and the function will yell at us because, hey, some user provided age instead of a name. So that's where you as a programmer kicks in and say, okay, but I need to prevent these mistakes, and either I want to handle them or prevent them completely by putting string, for example, that we already like learned in the previous hour or so. So that's up to you, but this is how you start building on top of what we learned so far and experimenting yourself. Okay, so let's just copy this example right here and say, hey, I like a square function that takes x and takes basically x times x and returns the value. So in the previous function right here, we just did something with data. So we didn't quite return the process data, we just printed out. Some functions are fine with that, but most functions that you're going to work with are going to return some value. Here, we put through 5, like imagine that you have like a cylinder, you have a 5 in input, and when the 5 goes through that cylinder, at the end, that's a 25 because the functionality inside that cylinder, which is our function, is multiplying that number by itself or square rooting it. So basically square rooting, what did it say? Sorry, I am tired. But squaring that number basically and returning 25. Okay. So this is not 2, but 25. Okay. So that's basically what happens here. And in this line right here, as you can see, we are still calling the function, but here we are providing some input to that function. Instead of x, we are putting 5, and we are storing that information to result. So you can basically use that result. Let me show you that. And we have this result that is 25. We can put that result again for the square root function. Square function. What? Result. Okay. Square. Okay. So you can basically stack those inputs together as many times as you like. Okay. That's basically what's happening here. We are going to do a couple of more things, and we're going to take a second break and then finishing with the whole session in about 45 minutes, I think. Okay, so sometimes you have multiple arguments. So far you had either a name or no argument at all. Then we scaled up to having an x as an argument and then doing something and returning that value. So imagine that you have a function called the my function, or just my f, for example, and then argument 1, argument 2, and we are just returning arg1 plus arg2. And when I call this result is equal my f, and for argument 1, I'm going to put, let's say 5, and for argument 2, I'm going to put 10. And when I print the result, it should return 15. So this function basically had 2 arguments. It can scale to even more than that. It can have tens, even hundreds of arguments. But here is another tip. Don't use more than 3 to 5 arguments. More than that will definitely ruin like the readability of your code, and especially when you collaborate with people, having like big functions, definition of functions that require like 10 different arguments to provide is not a great user experience from your end as a programmer, as a developer. So try to minimize the number of arguments to the function by creating multiple functions that each does something similar. And that leads to the second tip here. each function should do only one thing. When you need to explain a function, hey, it does this and this and this, you're not doing a great job of abstracting. So here, imagine that I'm squaring this arg1 as well. And then I describe this, hey, I'm squaring the argument 1 and then adding that to argument 2. That's a not good user experience from developer's end. So you would need to basically create another function, which I already have, square the 1, then put that square result here, as for example this. And this would work. This is fine. So basically that's what I wanted to tell you. Another thing is default arguments. So here we have arg1 and arg2. Imagine that I put 10 here. So in Python, you can provide default value for the argument 2. And you don't have to provide it at all when you're calling it if you don't want to change it. So if I just call it, it's going to still be 35 because this is default value of this is 10. But if you want to change it, you can put 15 and it's going to return 40 because we changed this. So Python will always take the default value if you don't provide it. If you provide it, the one that you'd like overridden with is going to be a high preference for Python. Okay. One thing that going to bother you, and a lot of my students are actually experiencing that error when they start with Python. So we previously provided Luca, like here, this. You can provide name is equal to Luca because the name is the name of the argument. I can say here arg1 is equal to 5. And then imagine that I want to override the arg2 by providing 15. This will yell. And it will tell you that positional argument followed by keyword argument does not work. So what it means by this is if you reference this first argument with the name arg1, the second one should be referenced as that as well. And this will work. However, you don't have to specify, and then you can specify. Like here, I use positional one and said the first one is going to be arg1, and then I call the second one, which is going to be arg2. Okay. So this is something that bothers a lot of people. And yeah, so I can move this into this area because that's for default values. Okay. Let's try that. Okay, I put arg1 and arg1, arg2. Oh, sorry. You can. So as long as you are basically putting that by the name, referring by the name, you can do in whatever order you would like. In that case, it's important for you to specify basically by name. Okay. It provides you a lot of freedom. The next thing is args and quargs. That is keyword arguments, which you basically ask right now. It's a bit more advanced topic, and lambda. So we'll do that after the break. So before we jump on a break, let me tell you what we have so far. So we'll go and explain args and quarks potentially. Maybe we'll skip that for now because it's getting late. We are in the third hour of a session. Then we're going to explain lambda, then classes, and potentially inputs and libraries. So I'll see in a break. We'll potentially skip classes and arguments and lambda functions. So I'll give you a lot of resources to read about them, because like those are going to be needed potentially in the second half of the whole course. But it's more important for us to jump on libraries, because that's going to be needed the next time. So obviously you can ask me in office hours any questions regarding quarks and classes and stuff like that. Maybe we'll leave them as a reading exercise after this session. So I'll come when I come back from the break, I'll tell you what is the decision. So see you in 5 minutes. Okay. How are you guys holding up so far? Is 3 hours so long? Or yeah. Tired of speaking. But it's going well. It's going well. I drank water, so I'm so far okay. Thanks for thanks for the question. Okay, so before we continue, just wanted to ask you, so do you want to skip the lambda and more arguments and like stuff that we can do with functions, and jump to libraries we're going to use for data science. And those can be your learning materials, and then we can go past, like, if you need the explanation, we can go and do them in office hours next week. And then right now jump on to the functions that we're going to use, or you would like to go through those right now? So I do use them in practical cases in projects, but not that often. So basically, right now, I feel that it's much better to understand, yeah, what are the libraries and why are those really important for us. Then we can brush about args and quarks next week. But I think you will never use them. Well, not never, but you will never use them in the course. That's what I want to say. Okay. So, yeah, classes are going to be really useful, but office hours is 1 hour. But we can always extend that if needed. So, but by default, it's 1 hour. It really depends on the questions, and if we go and jump on classes, yeah, we can always do that. Okay, so what is the real power of Python? So let me first show you this. If you go to pyp.org, let me try to, if somebody can paste that, we can do classes in a bit. So, but they are going to be useful not in the next couple of lessons. So Python packages, as you can see here, they have 432,000 projects, and all of them are different libraries for different use cases, like calculating time, doing mathematics, doing machine learning. We are going to use many of those. Releases are not important, those are just versions of those libraries. And this is basically the main reason, this number, which abstracts a lot. Let me zoom in so you can see, which abstracts a lot of information and a lot of things that we can use in our projects. When you start working with Python, you will build your own packages to increase your speed of your workflow and stuff like that. But this number is the main reason. And when we jump back to the code, when you scroll down, you have inputs and libraries. So basically, what's happening here, you have a weird syntax. Okay. This NumPy is the first library, and I think the one that you're going to use the most potentially throughout your data science journey. There will be 3 of those. We are going to explore, I think today, all of them. But NumPy is the first one. NumPy is numerical computation library. So matrix multiplication, working with tensors when you have like crazy big shapes of data and stuff like that, building neural networks. So you can build from scratch neural networks only using NumPy. So all of those can be done with this. It's built in C, so it's crazy fast. Like Python by default is slow, really slow. But then you have some libraries that are built in C, like C++ sometimes, and those have wrappings around them in Python, so you can reference them through Python, but basically speed is really similar to the original programming language. And here is how you import those in your programs. You start by import NumPy and then start working with it. The tricky thing about Python is every single library has its own documentation, logic. Different people are writing those libraries. So there will be some time for you to get used to certain library. Specifically like NumPy TensorFlow, Keras, all of those keywords that I'm just saying right now, you don't have to know them right now, are going to be tricky at the first, because you're going to had some like time getting used to the functionality, syntax and stuff like that. But generally, once you're getting like hands dirty in a couple of projects, repeating certain operations, you will remember the core functionality and where to find the information. Don't force yourself to remember everything. You will not remember everything. You will always need to Google or ask ChatGPT or Stack Overflow what certain function does or why it broke. That's normal. That's part of the game. So once I execute this, it will import my library, where I can start by saying numpy dot, and when you wait a bit, Google Colab will list every function that we can call. You can compare, you can copy certain, you can do cosine, you can, I don't know now, dot product, you can check the D type, you can check errors, for example, and stuff like that. So somebody asked what is the default floating point. So here you have a functionality to convert a certain point to float 16, for example, 32 and stuff like that. Okay, so there are many functionality. And why are you going to use them? Like right now, when I use this ARR1 and type of that, it's going to be NumPy and dimensional array. Okay, so that's not traditional Python thing that we saw so far. So it's not a variable from Python. It is in Python, but it's using like this library and all the functionality underneath it. So if you go and just call ARR1, you see here many things that you can call on top of it. You can transpose, you can get any, you can argmax it, so get argument on maximum number. The same thing for the smallest number. You can sort, argument sort, you can clip numbers, compress, and many different things. But then one additional crazy thing that happens right now because of this library, the traditional operators from Python start behaving differently. So right now, when I say plus 5 or 4, and then call it, right now, I'm going to add that number to all individual numbers or in this array. So this plus, because I'm like doing normal integer from Python and doing array from NumPy, it immediately becomes operator that submits or adds this 4 to all the numbers in the matrix. Okay, cool. So great, but what now? So you can call shape, and it's 3 point something. So that point will be so tricky to get used to, because that's by default. If you have only one dimensional array put through the NumPy, that's going to be happening. So let's add array around it and see what's actually happening in that sense, and call shape. So you can see that it's now 1, 3. So it's one dimensional like this, so it has 1 row and 3 columns. So imagine that this is a user that has 3 features for it: name, age, and I don't know, something else. Cool. So let's add the second user. So I'm going to add like this, and instead let's change numbers a bit. So let's say 4, 5, and 6. So right now we have a small data set that is shaped of 2, 3. So we have now 2 users, imaginary users. And if I print it out, it will have like this structure. Cool. So sometimes you want users to be like this. Sorry, you want to be users like this. So you would like to reshape them. So you can go and reshape, and then you're going to provide an argument that's going to state like what is the shape. So here we would like to have instead 1 2 or 2 3, let's say 3 2. So we are just transposing it, and you can do it by this. Okay, so right now you can multiply all the numbers by 4. You can do operations such as multiply this matrix by another matrix and have dot product. So all of these are now like you are unlocked basically to do all of these operations using NumPy. There are many more, but this is basically just the start. You can generate data sets with this. You can load the data set. You can load the CSV with array with NumPy. You can load images with NumPy. So all of those can be done with a single library. And because of that, because NumPy is one of the most popular libraries in data science, most libraries that you're going to see are built on top of it. Okay, so that's basically it. One more thing that is kind of supported by the industry, and let's say much easier to understand when you're reading code. Some libraries that are really commonly used, like NumPy, Pandas, sklearn, TensorFlow, and stuff like that, you're not going to import NumPy. Because like every time you reference the NumPy, you will need to do this, numpy dot something. So it's a bit tedious when you need to call it, let's say 10,000 times, which in some project that is the case. So you can import the NumPy as np. As np in this case, so as something shorter, you can put n, for example, and instead of putting numpy array, you will go and put numpy dot array. Okay, and now you are shortening basically and decreasing the size of your files, Python files, because you have to write 3 characters less every time you reference NumPy. So let's execute. As you can see, it works. So right now, if you would like to work with NumPy, you can go and np dot the same functions that we saw before are now accessible to us only by referencing np. Cool. So this is basically that for referencing libraries, and np is just a normal thing because everybody in the industry are using np. So whenever you start reading someone's code, you will potentially see np as a reference to NumPy. They are like pd for pandas, tf for TensorFlow, PyTorch, I don't know if it has some, okay, like torch maybe. So, and one more thing, like right now we imported the full library. You will see sometimes that we are going to import like this from NumPy, import, and now I only want to import array, for example. So I don't care of importing dot product, I don't care of importing neural networks or other stuff. I don't want to take all the advantages of NumPy because for this product, I only need array, for example. And from NumPy, I only imported this type, and that's what I'm going to use. So the good practice is if you know what you're going to use from a certain library, import only those functionality. And that's basically how you're going to keep your project smaller once they compiled, and also security reasons as well. Cool. So right now we are going to jump into like more practical thing for libraries for data science and machine learning. Like we already saw the opportunity that are provided by NumPy. So you're creating an array here, 1, 2, and 3. we are creating the second array with numbers 4, 5, and 6. And now you can see that we can we can add two arrays together, and every number will be added by corresponding number in another array. So here 1 plus 4 will be 5, so element wise. The same goes for multiplication, because we are not using this dot product, stuff like that. Then I said there is a sinus. You can mp.sen and then provide a, and it will calculate the that for every single item in the array. Okay, so this is basically happening in split of a second. It's really fast, and in most cases, like, it's so fast that you don't really need like to improve the speed, because the NumPy is so well optimized. The additional thing, like many algorithms such as sklearn are relying on NumPy for vector operations that we saw so far. So you don't have to like multiply two arrays or two matrices together in a for loop. You can basically do that with a single line using NumPy, and everything will be tuned down to C binding and actually executed there. The second library that you're going to use is here. So we are not going to execute and explore it right now, because that introduces a lot of complexity to explain every single thing. We are going to explore the pandas fully the next week when we start working with machine learning. But pandas is a library here for us that allows us to work with files. Mostly you're going to work with CSV files. You can load even Excel files using pandas. You can load many different types of files, but mostly CSV and Excel. Every single file is loaded as a data frame. That's where this df comes from. As you can see, in a single line of code, you can put like equal to pd.readcsv, and then put the name of CSV file that you like to read. And basically that. You can group by certain column name. You can take a mean of that of another column. Everything done in a single line of code. So you can see that how well this actually helps us to do complex operations on data in just a single line of code that we would need to write maybe a couple of functions even to solve the, for example, a group by operation. Here we are defining two data frames. Like we can do this. Let's comment this because we are not using any real CSV right now. So I'm going to create two data frames. Here, one which has keys A, B, C, D, and the other one be the E, F, and some random values. And as you can see, merges it, so as you would do in SQL, on a key, and leaves only the ones that appears in both data frames. So basically, most of the operations that you cannot perform in SQL, you will be able to perform using pandas, and much more. So performing operations on top of it, doing like calculations, connecting NumPy and pandas. So that is done as well. Filtering, processing, all of those stuff is considered ETL. We're going to use that in every single project that we are going to use in machine learning. So machine learning has a couple of stages. One of those is loading data, cleaning data, exploring data, stuff like that. So we are going to use all of those steps in upcoming weeks. Sometimes you would like to build, I don't know, a dashboard. So there are ways actually to export much of the data directly to Tableau or Power BI. There are bindings for Python that can do that. But then there are much simpler ways to do that while working with, for example, pandas, and you would like to visualize what is the distribution of certain column. Is there a correlation between that column and our target column? So all of those things we are going to explore what actually each of these terms means in next week actually. So here I'm generating simple like data and showing you just two graphs that you can do using third library that is really common in machine learning projects. That's called matplotlib. So matplotlib is there for us to basically show certain graphs, and basically, yeah, doing that. And you can see here that you can put histograms, you can do line graphs, you can do like dotted graphs and stuff like that. So everything that we are going to do, you can visualize directly either matplotlib. There are others like tkinter, qt, like there are much more with the GUI versions of it. But yeah, there is Seaborn that basically does the similar things to matplotlib, but with much better visualizations, for example. Okay, we got a question. So there is no need for SQL at all. It's a tricky. You can't do all of the things in SQL in pandas. There are other libraries that abstract SQL even more. That, for example, like when we are going to introduce SQL potentially in the future, so you can go and say table name dot filter, where name is equal to Sandra and age is equal to or bigger or equal to 45, batch all. So basically there are libraries called, specifically this syntax is coming from library called SQL Alchemy, if you would like to learn or read. But like traditional SQL can be really abstracted using Python. There is still need for SQL, like processing high level data, tens of thousands of lines of data is still possible, as I said, with Python, but sometimes it might be easier to build like processes in SQL and then just call them from Python or stuff like that. There is a way to read the whole SQL schema using pandas, but I never done that because my experience with that is not one against one. So there are still like errors that pandas introduce for us. So sometimes it works, sometimes not. It really depends, like what is the case, I would say. Okay, and the last library that we are going to mention right here is sklearn or scikit-learn. So sklearn is a library that we are going to use the most because, as I said in the beginning, this is a practical introduction to machine learning. We are going to learn about each of the libraries in the future, how it works, like what is the data behind it, what is the way that it behind it. We are going to measure some mathematics, so if you're not okay with the mathematics, don't worry. We will work slowly through mathematics. There will be not a ton of it, but just enough to understand what's happening in the background. sklearn, as many other libraries that we are going to use, abstract the level of machine learning to just one line of code. And as you can see here, there are a couple of terms that I'm not going to explain now. So loading a data set and splitting into different parts, making a linear regression model. Potentially some of you already know about linear regression. We're going to talk about it in the future. Fit is actually train. So you give it a training targets, and say, go learn. In one line of code, it trains. Then we call prediction, we predict, and then we make assumption on how well that model would work on unseen data. So obviously, that's not all. Like there are more and more libraries introducing, like TensorFlow, Keras, PyTorch, Hugging Face, OpenCV. All of those we're going to either work or mention throughout the program. But these 3-4 libraries that I just told you about are going to be the main part, at least by the week 6, until we join the era of deep learning, where we're going to actually go hardcore on deep learning and use more advanced libraries and algorithms. But yeah, so far, these are the algorithms, these are the libraries that we are going to use. For the model that we are going to use is, so for each algorithm, we are going to explain how it works, like either by visualization or by doing some maths, explaining how it works, like why certain algorithm would prefer this solution over this one, how to choose certain algorithms and stuff like that. And then we are going to use, for example, sklearn to train it. If we have hardcore users, then on the not open hours, but office hours, we can go and explore how to implement certain algorithms by hand. So using only NumPy. I have a couple of libraries that I built myself that actually goes through most common algorithms and implement them from scratch. So if you want to embark on that area, be my guest. But in the practice, when you get employed, you will never implement algorithms by hand, at least not traditional ones. So you're going to either use like high-level libraries such as sklearn, or some lower level libraries that are still high enough to actually rely on your knowledge. Yeah, I think that's it for today. We done a lot. If you never worked with Python, I try to condense as much knowledge as possible into one session. We didn't cover all by any means. Like there are certain things that we are going to introduce from lesson to lesson, but you are now at a good point if you revise all the things that we just spoken about. You're good basically to start working on certain things. And yeah, so the next thing and the next steps are for you to start exploring the libraries, start working with certain pieces of data. We are going to explore like CSVs. We are going to explore like crypto data as well. So yeah, basically that. Do you have any questions? You're welcome. Thank you for staying so far with me. We are just getting started. This is basically just the first session. The next one is going to be crazy one, like because we are just starting with machine learning, a lot of like concepts and stuff like that. But I do my best to introduce any level of people to AI and machine learning. Yeah, you're welcome. So we have 2 questions, I think from Luca. Okay. Okay, so we will talk about ML lifecycle of a project next week and week 3. I'm going to explore with you guys certain parts of ML project, like just to put in a perspective, because some of you are already developers, but not in ML sense, what it goes into building a certain ML project. So we'll go through ML lifecycle, not in details in a sense of building that project, because we are just starting to introduce ML as a concept to you. ML ops, for you that does not know, is like a DevOps, but for ML operations or ML models, like how to serve it to give it access to users, Our user are going to send the data to us, and then we are going to basically respond to that request. So it really comes to basically how your needs of users are going to be addressed through ML. That's MLOps. And MLOps is an area in itself. It requires more software engineering than just traditional machine learning. And there is a lot of demand for MLOps engineers in the future. In the course, I think we'll talk about MLOps in some guest lectures and potentially by the end of the whole course. But I did plan to organize additional course, advanced course for after this one, starting in end of April, beginning of May, that is going to tackle MLOps only. And it's going to be the same format, but it's going to be much more advanced. And it's going to assume that you're going to go through this to have knowledge of this course. So what is planned? The next week, we are going to speak about machine learning. So we are going to start with machine learning, classification. Then we are going to build a certain project, like small project, just for you to understand what it goes into building and solving one data set. Then you will have that quiz about that topic, and we'll have a small project on classification. For each project, you will have a time to do 1 week. So Friday to Friday. Quiz is still Friday to Friday. For quiz, you will need about 20 minutes of your time. It's going to be in Google questionnaire. So it's really easy, maybe less than 20 minutes. If you submit everything by that day, you'll be good to to be called to work with us. That's it. Then in week 3, we are introducing classification as like more advanced topic. So we are continuing and finishing with classification, and then introducing regression. Somewhere in between those sessions, we are going to introduce that life cycle that Luca asked. And then the week 4 is all about unsupervised learning. So we are finishing the traditional machine learning. We are going to unsupervised learning era, where you don't have targets, you don't know what you're trying to solve, you're just giving a machine learning a data and say, hey, find something. That's basically week 4. From week 5 onwards, we are switching gears to much more intense training on deep learning. I assumed you have a lot of questions there. How to get timing and link for subsequent week. Okay, so every single session will be streamed on the same link. So here you can follow this this account on Twitch every week, the same time, 5:30 p.m. I'll be here. The office hours again. I'll tell you on Discord, either here or Google Meet, because that should be more kind of personal. You have potentially some questions, and I would like to basically discuss not from chat, but through actually like conversation. So potentially Google Meet, if that's okay with you. And that Google Meet link, if we opt for that solution, will be sent to you guys on Discord. And that's it. Then week 5, as I said, we are going to jump to deep learning, and that's going to be crazy. And that week 5, we are going to talk about capstone projects. So some ideas, what is like expected from you, what can be done, like what is good for you by, like, for example, Luca talked about MLOps. You might not know about MLOps, but if he decides to go in that route, he can do that and present to and teach us all at the end of the session what MLOps is. So Luca can do that. Week 6, not ML6, is going to be dedicated to computer vision. So I'm going to teach you how to work with images, what is required to work with images and stuff like that. And in that week, we are going to speak about convolutional neural networks. After that, week 7, recurrent neural networks. Week 8 and week 9, advanced concepts of deep learning, transfer learning, ChatGPT, attention mechanism, building your transformer. So potentially we are going to build our own ChatGPT that week. We'll see that those 2 weeks. That's going to be crazy adventure. But at the end, you should have something similar to ChatGPT yourself. And then week 10 will be either the last week that you're going to work and present your capstone projects, or we are going to introduce week 10 and 11. We will see, depending on our group, reinforcement learning and competing against each other using MatchBox platform. So MatchBox has its own game that is a Formula One, a game that you can like write your own scripts and like statistics follow and like strategy and stuff like that to control your own formula. So if I manage to hack MatchBox platform, then we are going to use the platform to train reinforcement learning to basically get your own formulas to compete against each other in the group. So that's going to be exciting because reinforcement learning is crazy topic, and I would love to teach you that. But we will see. Like either skip that or cover that as well. We'll see. So yeah, that's the plan for next week's. Yeah. Thank you guys. So if that's all, if you don't have any questions, you can always ping me on Discord. Oh yeah. It's completely okay. Like you can always submit the project directly to me through Discord, as I told you, so you don't have to give me email. The only reason, like if you would like to work on projects, obviously there is need to tell the information, not to me, but to people who would like to hire you, not to me. So I don't need your information at all. So yeah. Yeah, cool. So thank you for a great session, and thank you for staying this late. I'm so happy to have you guys here, and see you next week. In the meantime, if you have any questions, please ping me. Otherwise, see you in the office hour. Bye.